Today's daily dose of math involves being given a linear situation and then being asked to change one of the parameters of that linear function and then use the new changed function to answer a question. The biggest challenge for me was trying to fit two examples on this chalkboard at once. Let's just look at the one on the left for now. It's machine rental. We're renting some sort of machine, and we have y equals 15x plus 85. The x represents the number of days, and the y represents the cost in dollars. Now we could calculate if we were to pay a certain amount, like this 175, how many days would it take? How many days would we get the machine for? But that's not what we're asked to do right now. They've changed something. The daily cost doubles, but the fixed amount remains the same. That means this daily cost of $15 is doubling to $30, but the initial amount that you pay, the $85, doesn't change. We need to answer our question using a new equation where we've changed that parameter. So 15 times 2 equals 30. That tells us that the 15 is now a 30. Y is equal to 30x plus 85. Now we use this to answer our question. If y is $175, we replace the y with the 175, and then we do algebra to isolate our x and answer the question. 175 minus 85 will be equal to 30x. 90 equals 30x. We divide both sides by 30, we isolate our variable, and x is equal to 3, and the unit of measure is days, as we said at the beginning. Let's look at example 2. We're paying back a loan. The equation is y equals negative 200x plus 8,000, where x represents months and y represents the amount that remains in the loan. But the client changed their mind. They went back to the bank and they increased the amount of loan by $1,500, but the payment size per month remains the same. How long until they owe $1,100? We could plug $1,100 into the y position of this equation and get an answer, but it won't be the right answer because we have to change the amount, the initial amount borrowed first. So 8,000 was the original amount, and we added 1,500 to it. We now have an initial amount of 9,500, and the equation will be y equals negative 200x plus 9,500. Now we can plug in $1,100 again into the y position. Now I'm rapidly running out of room, but I'm going to move the negative 200x to the other side. So we have 200x equals, and I'm moving the 1,100 to the other side, 9,500 minus 1,100, which gives 8,400. We divide both sides by 200 in order to isolate our variable, and x is equal to 42. The unit of measure is months. It will take 42 months before you only owe $1,100 using the new equation after the change. So what these examples are really doing is changing either the slope or the y-intercept of the linear. In this case, we're changing the slope from 15 to 30, but we're keeping the y-intercept at 85. And then we're able to use our new equation to answer a question. In this case, we are keeping the slope at negative 200, and we're changing the y-intercept, the initial value, from 8,000 to 9,500. Then we use the new version of the equation to answer the question. This is today's daily dose of math. Don't forget to like this video and subscribe.